We're going to start on the subject robotics. What can you tell me about this image?
The artist is trained to express movement.
Yes, the artist Boccelli was trying to express movement. Boccelli was one of the futurists. Futurists were using a technique about placing several views of an object. In this case, are the legs. The objects are the legs in the sculpture. So here is one of the views, another view, and another view. So the views are mounted together in the same sculpture, and that produces the sense of motion that Boccelli was trying to express. And Boccelli also didn't place the arms in the sculpture, so we focus on the legs. The first theme in robotics is kinematics. But to start with kinematics, we have to define first what is motion. Motion is the rate of change in position of an object over time. That is motion, and motion has two very important parts: the causes of motion and the effects of motion. So what causes motion? In this image, we can see a person pushing a car. He's applying a force to the car and expecting the car to move to this side. Okay, and what it is then related to the causes of motion are the forces, the torques, and somehow the masses and the inertias. So what are the effects of the motion, or how we sense or measure motion? We measure it through displacement, distance, time, etc. And now we can state what it is: kinematics. It's a branch of classical mechanics that describes motions specifically using position and velocity. Position and velocity are things that we can measure about motion, so are effects of motion. And the kinematics disregards the causes of the motion. So the causes, as we mentioned, are forces, torques, masses, and inertias. So when we speak about robot kinematics, we're speaking specifically about a relation between the values of the joints in the robot and the position and the orientation of the tool. So in order to do that, we normally place a reference, a coordinated frame in each of the joints, a reference frame in the base of the robot, and a final frame in where the tool ends. So the relation will be between the final frame in the last part of the tool relative to the frame in the base of the robot. And in this image we can see some similitudes between a person and the robot. Which are those similitudes? Normally we can say that there are three joints associated with the position of the tool in the space, and three joints associated with the orientation of the tool in the space. So the first three joints in the case of the human are the waist, the shoulder, and the elbow, are called the arm, and the arm is giving the position of the tool in the space. And the three last joints are associated with the wrist. The wrist then provides the orientation of the tool. That in the human is the hand, and in the robot is some other tool. So in the robot we can identify those two parts, those two primary parts too: the arm with the first three joints, and the forearm with the wrist, that are three joints. The nomenclature in robotics to do this is, for the joints, is normally a Q letter with subscripts 1, 2, and so on. And normally associated to each of the joints there is a frame, as we have just stated. Here is an example of an application of robots and what is kinematics within this video. Kinematics helps us to relate the changes in the values of the joints with the changes in the position and the orientation of the tool to interact. Okay, so that is robot kinematics. And robot kinematics can be broken down into two smaller problems. First, it is the so-called direct kinematic problem. That is, if I know the values of the joints, of the robot, then I should be able to determine the position and the orientation of the tool. Okay, so given some values of the joints, let's determine an equation through an equation the position and the orientation of the tool. Okay, that is direct kinematics. Inverse kinematics is exactly the opposite. If I know the position and the orientation of the tool, I should be able to determine which values of the joints produce that position and that orientation of the tool. Okay? That is inverse kinematics. And so we have seen all the concepts related to kinematics, and we can start with the activity. To start the activity, you have to enter to the site kahoot.it and type in a corresponding game pin that I will provide, such as this one, and then you enter a nickname and wait for the quiz to start. First, you will see here in the screen the question and then the possible answers. Those possible answers are related to a color and to a figure. So you'll choose in your device or in your computer the corresponding color or figure. So let's go to Kahoot. Please enter to Kahoot and you'll see a screen such as this one. Are you ready?
Yes.
Okay, first let me start to produce the game pin. Let's wait a little. This is the game pin. Please enter. It's 25, 65, 86.
Okay.
Okay, I'm going to introduce it here and then click enter. I will enter a nickname, Armando, and click OK Go. So I can see you here, and here is me. Let's start. So here it is, the first question. Choose an answer, please. Okay, are you ready for the next one?
Yes.
Let's go for the next one. Question 2. Time up. Let's go for the next one. Are you ready?
Yes.
Let's go. Question 3. Choose an answer. Okay. Are you ready for the last one?
Yes.
Let's go. Choose an answer. Okay, so we are done. Let's see the podium. You are in the first place. 4 out of 4. Great. Congratulations. So we have finished and we can download the results as evidence of this activity. And that will be all. Thanks.